Hello everyone. Today we are going to be looking at quadratics, particularly looking at the graphs and what we can learn from the graphs and how we can use them to actually know some different features of a parabola. So we're going to start by looking at just a general parabola. I know you don't have this in your notes, but if you can find some empty space to work in, we're going to draw a parabola and just label some different features of that. So I have a graph here. I'm going to draw my parabola on here. And that parabola again is that U-shaped graph. We've looked at that a couple different times this year, but we do want to make sure we look at it. First point I want to look at is that point that's at the very bottom. This is a word that we've used before when we looked at absolute value functions. Okay, that value or that point at the bottom is what we call our vertex, and that is that point at the bottom. That is an important point for us. That is one that we are going to use over and over. Okay, I'm going to adjust my graph here a little bit. I want this to cross my y-axis here just so I can talk about that point as well. That point where it crosses the y-axis, that's one we've talked about a ton in this class. That is what we call that y-intercept. And just like when we have a straight line, when we have a parabola, that y-intercept is helpful for us as well. That's something we can use to talk about our equation. Alright, so now that we've looked at vertex and our y-intercept, let's go ahead and get started with in our notes packet for what is there. So first thing I want to look at is if we look at a general parabola down here at the bottom right, we can notice that there is a line of symmetry there. If you remember, line of symmetry is when we take a figure and we kind of flip it over on itself, we get the same thing that we have. So if I have this parabola down here, I can take the right side, flip it across that dotted line there in the middle, and I get the other side of my parabola. That line there, that dotted line, is what we are going to call our axis of symmetry. Axis of symmetry. That's going to be a vocab word that we just need to learn, and that's our word that we're going to be working with a lot today. One thing we need to know about that axis of symmetry is it goes through my vertex point down here on my graph. It goes through that point. We've labeled that vertex down here with H and K. That allows me to say that that line there goes through that point HK. And I can see that this is also a vertical line. So if I look at the equation of a vertical line, that is always x is equal to, and now it's going through that x value of h in that vertex. So our equation for that axis of symmetry is always x is equal to h, or that x coordinate of my vertex. Okay? If you look right above here, there's this form of a quadratic. This is what we call vertex form. We haven't looked at that quite yet, so go ahead and cross that out. We will get to that later in our chapter. But that is our axis of symmetry, so let's go ahead and look at some other properties of quadratics. This equation here is the one that we really want to be working with. That's that ax squared plus bx plus c. We looked at something similar to that when we were factoring things last week, as far as when we can factor out those quadratics. Here we just want to know that we have to have values for a, b, and c, and a cannot be 0. If a is 0, that term's going to drop out, and we just have a linear function, and we're really talking about quadratics. So that's what I want to look at. The first property of these parabolas that I can tell from that equation is which direction this parabola is going to open. Is it opening upward to where I have that U shape, or is it going to flip around and open down to where it's kind of that frown face or an N shape? Okay, and that is all based on the a value. So if you look in here kind of in the middle, it says that that parabola opens up if a is bigger than 0. That's when we would say a is positive. Go ahead and label that in there, a is positive. Or if it's opening downward, that means it's less than 0, or a is negative. So based on that a value, just the sign of that a value, I can decide whether I have a positive or a negative. Okay. Next, I want to look at this axis of symmetry piece. Again, that axis of symmetry we looked at just a minute ago goes straight through the bottom of my parabola, through that vertex. And the equation for that line is x is equal to. Because it's a vertical line, it's always x equals to. And we get this expression here, negative b divided by 2a. That is another one we're going to need to learn. That is how I can find my vertex or my axis of symmetry. Okay, that's just an equation we need to know. There is a reason that that shows up. I'm not going to go through that in this video, but if you want to see that when I get back tomorrow, I can show you that as well. Okay, but that is how we can find our axis of symmetry. That same expression, that negative b divided by 2a, shows up again when I look at my vertex because I know that those x coordinates are the same. So my x coordinate here is that same negative b over 2a. This next part here where it says f of negative b over 2a, I want to cross that out. Okay, that's going to be a little bit more confusing than we need to be. What I want to say is we are going to say pxi. Right? Pxi is an acronym that we are going to use, so it's kind of a shorthand. Pxi, that stands for plug x in. Okay? What that means is I'm going to find my x value first. I'm going to take that x value, plug it into my equation, and it's going to spit out my y value. That's the easiest way to find our y coordinate of that vertex. Last thing we want to look at here, that y-intercept is c. What that means is on my graph over here where it crosses the y-axis, that is going to be the same point as just that c value from the equation. So I can ignore everything else and just look at that c value, and that's going to give my y-intercept. Alright, so I know that was a lot of information all at once, but we're going to go ahead and work through a couple of examples that's going to use all of this information as well. So let's go ahead and get started. I have this equation here, 2x squared minus 4x plus 5. And in that equation, I'm going to work with this for a while here, and I want to find kind of all of those properties that we just talked about on the last page. So my first part here, A, is whether the graph opens upward or downward. That is again based on the A value, and that A value is the one that goes here with x squared. So here my A value is 2. If A is 2, that means it's positive. And it's a positive 2. And if I look back at my notes, that positive means that I am opening upward. Okay, so I just need to say upward there, and I'm done. It's that easy. I just got to look at that A value and find my answer. For part B here, I want to find the axis of symmetry. For the axis of symmetry, I need to use that expression that was on that last page, which was negative b over 2a. Okay, this negative here can either go on top or bottom. It's usually easiest if we just throw it up here with the b. There's a little less going on up there. So we're going to put that negative up there. Now I can plug my values of a and b into that equation. So we already said a was 2. My b here is the negative 4. I do need the negative to go with it, so I need that sign in front of it. So I have a negative 4 on top. Okay, we'll talk about what that becomes in a second. And then 2 times a, where that a was 2, so just 2 times 2. Now I need to simplify that out. If I am subtracting a negative, or I have 2 negatives here, we talk about that becomes a plus. So this is a plus 4 on top. And then 2 times 2 will also give me 4. So I have 4 divided by 4. If I have the same number divided by itself, if I reduce that, that's just going to give me 1. Okay, so I know that the x coordinate for that axis of symmetry is at 1. I want to write the full equation though, so I just need to say x is equal to 1. That is my final answer there. Just need to say that x is equal to 1. At that point, I have found my axis of symmetry. I can move on to the next one, so let's go ahead and flip to the next slide, and we are going to try and find the vertex. We've already actually found half of that vertex. We just found that x was equal to 1. That was from that axis of symmetry. Axis of symmetry. I'm going to abbreviate there, axis of sim. And that's that axis of symmetry piece. And we know that the x coordinate of our vertex is the same as that axis of symmetry. So I already have my x coordinate. Now I need to find my y coordinate. If you look back in our notes again, that y coordinate, we said we are going to pxi, which stood for plug x in. So I want to take this x value and take my equation, which I said was f of x is equal to 2x squared minus 4x plus 5. And I'm going to take that 1 and plug it in for x. So I'm going to have 2 times 1 squared minus 4 times 1 plus 5. Now I want to talk about something real quick with order of operations here. I have 1 squared. I need to square this number before I multiply by the 2 or whatever number is in front here. And that's a very common mistake I see. We'll see people multiply these two numbers together and then square. I need to follow over order of operation and do the exponents first, so I need to square first. But 1 squared is just 1, so then when I multiply by 2, I still have that 2. 1 times a negative 4 is still negative 4, and then I can add the 5 at the end. Now we need to subtract those and add them together, so 2 minus 4 is going to give me a negative 2. plus 5 will give me a positive 3. Okay, and again, that's our y coordinate, or that f of x. Those are the same notation. We've been working with those for a while. So I have x is 1, y is 3, so those coordinates for my vertex is 1, 3. And again, I want to write that final piece kind of like we have the equation for axis of symmetry. I need that final step there. Last one here is going to be to find the y-intercept. That y-intercept was based on our c value, which here is just that 5, and it's just the c value. So c is equal to 5, so my y-intercept is 5. Okay, that should be one of our easier steps here. Y-intercept is just that c value, which here is the plus 5. Alright, now what can we do with all of this? What we can do with all of this is actually graph this function. So I've given you a graph here, and when we're working with graphing these, I'm going to use all of those pieces we found on the last slide. So I know, based on part A for this equation, it's going to open up. I know my axis of symmetry is at 1, I know my vertex is at 1, 3, and I know that my y-intercept is at 5. So let's go ahead and start by doing the vertex first. So just like when we had a absolute value, I want to start with that vertex. So we said our vertex was at 1, 3, so I can put that point on my graph. If I go to the right 1 and up 3, that is my vertex of my equation. I know I'm opening up, so that's going to tell me that my u-shape is going to go up, but I still want to get another point to kind of help me out here. So I have that the y-intercept is at 5, so I'm crossing that y-axis here at 5. That gives me another point. So what I want to do now is I want to connect my vertex and my y-intercept and draw a nice smooth curve going up, because this one is going to open up. Okay, notice that I just drew half of my parabola here. Now I know that it's symmetric across that line, x is equal to 1. So across this line here, it's going to look the exact same. So I'm going to use that fact that this is symmetric across and draw in the other half of my parabola. Again, these are kind of just an estimation. I want you to do this as well as you can. Okay, we're going to eventually get to the point where we can use our calculators for these, and they'll be a little bit more accurate, but even those we're going to be estimating once we see the picture. So we want to be able to do this by hand and kind of get that idea, but we can also use our calculator here in a minute. Alright, we have another example here. I'm going to go through these pretty quickly. You should be able to do these on your own as well. Okay, so our first part here opens upward or downward is based on my a value. A here is a negative 1. Okay, if it's not there, there's really a 1. So that negative tells me that I'm going downward. I'm just going to circle that here just to move quickly. Next, I'm going to be looking for the axis of symmetry. For axis of symmetry, I need to use that kind of expression negative b over 2a. My b value here is a negative 2. My a is a negative 1. So if I plug those in, I have a negative 2 over 2 times negative 1. That's going to give me a positive 2 over a negative 2, which tells me that my axis of symmetry, if I reduce that, is going to be at negative 1. So my equation is x is equal to negative 1. Excuse me. To find the vertex, I have my x-coordinate now we said was negative 1. I need to find my y-coordinate by doing my pxi, or plug x in. To do that, I'm going to take a negative 1 and plug it in for x. As I do that, we're going to end up with this equation here. So I have negative 1 squared minus 2 times a negative 1 plus 3. Now I need to start by simplifying. I need to do my squared first, so I need to take negative 1 and square it. That's going to give me a positive 1. So now I have a positive 1 here, but I still have a negative out front, so that's going to end up making it still a negative 1. But I got to go through that whole process. Now I have negative 2 times a negative 1 gives me a positive 2, and then a plus 3 at the end. If I work all that out, I'm going to get that my y-coordinate here is 4. So the coordinates of my vertex are at negative 1 and 4. Part D should be super fast for us. This is our y-intercept. Just need to look up here for my c value, which is 3. So c is equal to 3. My y-intercept is just at 3. Alright, again, I want to try and graph this thing. So so let's go ahead and get to the next slide here. I have a graph, same equation, just trying to graph it. So if I look, my vertex was at -1, 4, so I want to plot that point first. My y-intercept was at 3, which is right here. Now I want to draw in that half of my parabola, and it's going to go something like that, and I want to make it symmetric on the other side. All right, just get as close as you can so where it looks the same on both sides there. All right, and that is our graphing and using all of those properties. Now we also want to talk about domain and range for our quadratics. If we remember, domain here referred back to our x values, our range referred to our y values. So if I look at a graph of a quadratic, let me pull that one we just did back here. When I'm looking at my x values, I want to know, is it possible for me to get all of my x values here? And hopefully you're thinking to yourself that I might, but it's going to take a while because these are going down super fast. Okay, so as these go down faster, I'm still going to be moving out, so eventually I will get to all of these x values on both directions. It's just going to take a while. Okay? But I will eventually get to them all, so we're going to say that our domain here, or that x value, or those x values, are going to be all real numbers. Okay, all real numbers. If you remember the notation for that, we have that special R looking thing. Okay, that is all real numbers. Now the range, if I look back at my quadratic, and I'm going to pull this one back in, our range is all of our y values. And so if we have a parabola that either opens down or up, there's going to be some y values that I'm missing. Up here it's the ones that are above it, or if I had one opening up, it'd be the ones down below it. And so those values are going to depend on two different things. First is going to depend on where the vertex is. So it's depend on the vertex. It's also going to depend on which direction it opens, because even if I'm at one vertex, I could be going up or I could be going down. So it's also that direction that the parabola is opening. So either going up or down. Alright, so let's go ahead and talk more about up and down, opening upward or downward. When we talk about upward and downward, we get two new points that we need to talk about. Those are going to be what we're going to call our maximum and our minimum. Okay? A minimum value, that's always our low point. A maximum value is what we're going to call our high point. Okay? And hopefully those make sense to us. Just our maximum and min, we've worked with max and mins before. Okay, so our low point is our lowest value, our x point is our highest value. If I have a graph that's opening upward, so I get that U shape, I'm going to have a minimum. It's going to come down to a point, and then it's going to turn around and go back up. That point at the bottom, or that vertex, is going to be my minimum value. However, it's not both coordinates here. The minimum value is just that y coordinate, so it's just going to be my k value on that vertex. It's not the ordered pair, it's just the k value. And so when we look at our range, if I have something that's opening upward, I'm going to say that my range over here is when my y's are greater than my k. Okay, so I have y is greater than k. If I shift over to when I'm looking down, if I have a downward, this is where everything's going to come up to a point and then turn around and go back down. So I get that high point or that maximum. Again, it's just going to be that k value on my vertex, not the whole ordered pair, just the k value. And so if I look at the range here, I would have that y is less than or equal to that k, because that's the high point. Everything else is going to be smaller than that. I do want to quickly mention this again. We have this giant caution box here on the bottom, and it says that our minimum or maximum value is just the y value of that vertex. Here we were calling it that k coordinate. Okay, it's not the whole ordered pair, it's just the y value. Okay, that is something that if you did on a quiz or a test, you're going to get marked down for. You've been warned. Alright, let's go ahead and look at finding our minimum or maximum and deciding on our domain and range. Okay, as far as step 1 and step 2 here, those are going to stay. There's not really going to be a step 3. Okay, but we can look at step 1 and step 2. Step 1 and 2, I have to decide first, am I going to have a maximum or a minimum? That's going to depend again on what direction I'm going. Am I going opening up or am I opening down? And all of that depends on my a value. So my a value here is that -3. So I'm trying to decide, do I have a max or a min? And I know that a is equal to -3. So that negative 3 tells me that I'm opening downward. If I'm opening downward, everything's going to come up to a point, and that point there is going to be my maximum. So I'm going to have a maximum here. And again, I'm going to start using max and min versus maximum and minimum, just so it's easier to say and quicker. Okay. My step 2 now is I need to actually find where that maximum is going to be. The way I do that is I need to find my vertex. Okay, so my second step here is to actually find the vertex. That maximum, again, is just the y-coordinate of the vertex, but in order to find the y-coordinate, I have to know the x-coordinate first. So I need to use that negative b over 2a, and I need to plug in my numbers there. So I have a was negative 3, b is going to be 2. So I have negative 2 over 2 times negative 3. If I simplify that out, I have negative 2 over negative 6, or 1/3. Once I have that 1/3, I need to plug 1/3 into my equation. Okay? This is where we got to remember our fractions. Okay? I have negative 3 times 1/3 squared plus 2 times 1/3 minus 4. At this point, I need to square this 1/3. If I square a fraction, I need to square top and bottom, but 1 squared is just 1. 3 squared gives me 9, so I have negative 3 times 1/9 plus 2 times 1/3. That 2 will go into the top, so I'll have 2 over 3 minus 4. Now I need to multiply by negative 3. That'll go into the top as well. So I have negative 3 over 9 plus 2/3 minus 4. Now I can reduce negative 3 over 9. That's going to be a negative 1/3 plus 2/3 minus 4. So if I have 2/3 and I'm adding a negative 1/3 to it, that's the same thing as doing 2/3 minus 1/3, which would leave me with 1/3 minus 4. When I have 1/3 minus 4, you could either now kind of jump over to a calculator and do 1/3 minus 4, you'll get a decimal, and you'll want to change that back into a fraction. Or I would know that 4/3 would be the same thing as 12 over 3. I need those common denominators. And 12 minus 1, or 1 minus 12, will give me negative 11 over 3. So my answer here is going to end up being negative 11 over 3. And that's that y-coordinate, which is going to be my maximum. So my max here is negative 11 over 3. I know, I started out nice and easy for us with a fraction. So I found my max and min now, but I am also asked to state my domain and range. If I look at my domain should be nice and easy for us. We always know that our domain for a quadratic is all real numbers. Nice and quick. I'm done with domain. Now let's look at range. Range I have to be a little bit more careful of, but this maximum here tells me that that's the highest y value I could have. So everything else is going to have to be smaller. So all of my y values are going to have to be less than or equal to that negative 11 over 3. Okay, so that is our first example there. I'll leave it there for 1 second. Make sure you get all of that copied down. All right, and real quick, one more example here. I want to find my max or min value and state my domain and range for this equation here, x squared minus 6x plus 3. For this one, my a value here is 1. That's going to tell me if I have a minimum or maximum. That positive 1 tells me I'm opening up, so I'm going to end up having a minimum here. To find that minimum, I need to find my vertex. So I would have negative b divided by 2a. My b value here is negative 6. My a is a 1, so I have minus a negative 6 over 2 times 1. And if I simplify that out, I'll have 6 over 2, or 3. Okay, so my x-coordinate here is 3. I can plug that into x squared minus 6x plus 3. I'll plug the 3 value in for x. That gives me 3 squared minus 6 times 3 plus 3. That's going to give me 9 minus 18 plus 3. 9 minus 18 would give me negative 9, plus 3 is going to end up giving me negative 6. So my minimum value here is negative 6. That's as small as my y's are ever going to be. Now I want to state my domain and range. My domain should be nice and easy. That's all real numbers. My range here is going to be y is greater than or equal to that minimum, which is -6. Okay? Alright, that is all that I have for our video today. You are going to finish the rest of the hour by working on homework. Your homework is posted on the back board. Your substitute also has all of those problems as well. If there's any questions there, let me know. I am available by email today if you want to shoot me an email with any questions, and I will be back tomorrow, and I am available after school as well if you have any questions or whatnot. Alright, I will see you tomorrow.